number here, which is fairly small. I'm going to be adding multiples of 2 pi over 5. And I want to add something less than 2 pi. Well, 10 pi over 5 is 2 pi, right?
Mm-hmm.
So if I add 2 pi over 5, that's not going to make it too big. If I add 4 pi over 5, that's not going to make it too big. If I add 6 pi over 5, that's not going to make it too big. And if I add 8 pi over 5, that'll be okay.
Or we could just keep going until we get to something under 2 pi, or 2 pi itself.
Yeah.
So that's just setting your range then, basically.
Yeah. The problem is the first one is going to be fairly negative and small, so you're going to have to add 2 pi over 5 to get, yeah.
What do you mean? It's gonna be,
Well, let's go ahead and do it then. So if I add, boy, if I make this negative, right, and I add 2 pi over 5, so 2 times pi divided by 5, I get this value. Notice that that's positive, right? So that's a good value. So I could paste that one in there, and I'd have 2. Paste and trim. Trim to where? About to there. Okay, so now go back to the calculator and say, recall.
It says only two,
The smallest.
the two smallest solutions.
Oh, enter in the 2 smallest solutions. Oh, yeah.
That's it.
The smallest 2 solutions. I think these are them.
Yep.
That's when K was 0.
Right, oh, good. So that saves us a lot of trouble. In fact, there will be 10, but these are the 2 smallest ones, right? So, yeah. Thanks for pointing that out. Saving me a lot of anguish and computation. All right, so, yeah, so here, this is more like a benchmark value here, right? So, do we have some identity that helps us here?
Yep.
Yeah.
Whatever minus the unknown.
The cosine.
Yeah, so it's cosine, cosine, sine, sine, that's gonna be cosine of the sum, which is the opposite. There you go. So this would be cosine of 3x is equal to cosine of 2x plus x, which is cosine 2x, cosine x minus sine 2x sine x. So we were given this, and we can substitute for it that, right? So now we have the equation cosine 3x is equal to negative square root of 3 over 2, which is a nice benchmark value, so we don't have to do weird decimal approximations.
so, can you do that again, how we got the cosine 3x? I didn't catch it.
Sure. So if we start with cosine 3x, I kind of had to work my way backwards to this, right?
Yeah.
So I say, look, if I had this sum, then that would be this. And the cosine of this sum is cosine of the first, cosine of the second, minus, because it's the opposite sign, right? Cosine. Sine of the first, sine of the second. And so that gives me a much simpler equation, right? So where is cosine equal to negative square root of 3 over 2? Well, that's going to be here and here, right? Where this is negative square root of 3 over 2. At this point here, about 0.866, negative 0.866. And so what's this angle here? 5 pi over 6, right? Yeah. We should be fairly automatic with those from last semester, right? Or negative 5 pi over 6 here. Or 7 pi over 6 if you want to think of the positive angle, right? And they want angles in radians in the interval from 0 to 2 pi. So we're going to say, yeah, cosine, well, 3x is going to be the angle whose cosine is negative square root of 3 over 2 plus 2 pi k, right? Plus, in general, plus or minus here, right? And then so plus or minus 5 pi over 6 plus 2 pi k. Then divide by 3, right? So you can have x is plus or minus 5 pi over 18 plus 2 pi k over 3. How are we doing?
So to get the cosine 3x, we use an identity to pretty much, combine them together. Alright.
Well, it's not really an identity, it's the inverse cosine function. Right? So the inverse cosine function will give us just this 5 pi over 6.
Okay.
But when we say plus or minus, then we get the 5 pi over 6 and the negative 5 pi over 6. And when we put in all the coterminal angles, you get this, right?
We use the 7 pi
Yeah,
over
so
6.
that-
And then we divide through by 3. So save the dividing through by 3 until you've got all these angles in terms of k. Then divide both terms by 3, right? Not
Yeah,
just
so
one.
that part I understand, just like, I guess, at the beginning, you told it to me once, but I didn't wanna ask it.
This again?
Yeah.
So if we start with cosine 3x, we can write 3x as 2x plus x. And then this is just the addition identity, right?
But I mean, we started with that, with the addition identity.
Yeah, so you kind of have to learn to think backwards on that. If you've got something that fits the pattern of the addition identity, you can use it.
Yeah, because
It makes it a lot simpler.
in the addition identity, basically that 2 just goes to the first cosine and the first sine, the x goes to the first or the second cosine and the sine. Isn't that a way to think of it?
Whatever works, right? It's one of those things you just have to memorize it.
I mean, but that is true though, isn't it?
Which?
Well, the 2x on the, so yeah, the 2x plus x in the parentheses, correct?
Yeah.
That 2x would just go to the first cosine and the first sine.
Well, you can reverse these, yeah.
They can be reversed. Okay,
Yeah.
so it just goes to one of them, and then x would just go to the other one.
Yeah.
And then you just throw the opposite sign in the middle.
Right,
Okay.
yeah. So then what are these? Well, you're gonna have 5 pi over 18, right? We don't want any negative ones, right? So we're gonna have to say negative 5 pi over 18 plus, what is this, is 12 pi over 18? Same thing? Maybe easier to think of it as 12 pi over 18 rather than 3 pi over 2, huh? Or sorry, 2 pi over 3. Right, same thing, right? So then it makes it easier to add. So if it's negative 5 plus 12, that's going to be 7 pi over 18. Right? Or if I add 12 pi to positive 5, I get 17 pi over
Pause for a
18.
second.
Yeah,
All right, so the 7 pi over 18 is if you assume that we're working with negative 5 pi over 18 plus 12 pi and k is 0.
yeah. So
Right.
we only get one value for k equals 0 because the other one is negative.
Right, it's plus or negative.
Yeah.
Okay, and it can't, our answer cannot be negative pi. And-
Right, it's got to be bigger than 0 and less than 2 pi.
Okay,
So I only get 1 then when k is 0. When
Okay.
k is 1, I get 2.
okay.
When k is 2, well, let's see. So I'm going to be adding 12 again. So I'm going to get 19 pi over 18. So you kind of see the pattern, right? 5 pi over 18, add 12, you get 17 pi over 18. 7 pi over 18, add 12, you get 19 pi over 18. And if I add 12 to this, I'll get 29 pi over 18. That's again k equals 2, right? And that's less than 2 pi, right? Now when k equals 3, I'm going to get only one more value, and that's going to be for the negative, right? So I'm going to say the smaller of these was when it was negative, right? So I added 12 pi over 18 to 7 pi over 18. I'm going to add another 12 pi over 18 to that and get 31 pi over 18. You see the patterns in here? I mean, it's,
Oh yeah, that part is easy,
yeah, okay.
just like the,
So there's 6, right?
yeah.
Which, ordinarily with just x, we'd have 2. Since it's 3x, we have 6. What are they? Well, they're 7 pi. When is the smallest one?
5 pi
5 pi.
18.
Over 18, comma 7 pi over 18.
It's not.
Yeah,
It's not
Your
typing
previous
properly.
year.
You have to use the parentheses for the pi's.
I think it's all right. It's okay.
That's not.
Yeah, it works.
Yeah, I mean 5 times pi over 18 is the same as 5 pi over 18. You know, it's that kind of thing that
Huh.
throws people out. You know, that's
Wow.
different. No, it's the same thing. Five times pi over 18, 5 over 1 times pi over 18. Oh. And so then what, 17
You did it?
pi over 18, 19 pi over 18, 29 pi over 18, and 31 pi over 18. Is that all of them? Yeah, all multiples of pi over 18. Okay. He likes them all. Good. Sine 2x equals cosine x, is that an easy one? Kinda easy, isn't it?